¿Vas a decir que esperamos un minutito para que se llene?
Hello, everybody. This is Julian Mackern from Wingtra. And here we have
And I'm Erik de Badts from Micasense.
Can you also see the participants, Erik, coming in?
No.
No. I see lots of people we already know from all over the world, everywhere in Latin America, the US, Europe, APAC. Thank you all for joining. This is good to see the list going up. It's already reaching 80 people. Canada as well. Some of you might know me already from Wingtra, having talks around multispectral. I guess you also know Erik.
I'm looking at the list now too. Many people that know us already. It's nice to see that people are dropping in. Very excited that everybody's interested in this this nice combo of products, right?
Nice bundle.
Nice bundle, yeah. So yeah, let's give it another 2 minutes.
Yeah.
So we can expect everybody to join.
I'm really curious to see how many are already flying Wingtra and how many are already flying with Micasense sensors.
For sure. Yeah, I think many people that are having our sensors are looking for a fixed wing drone. Many people are just working with multispectral, so they for sure are eager to learn about the capacities to start flying with a VTOL. And the other way around as well. I think many VTOL users are currently working in survey applications. They might be interesting for one of these jobs that drop in once in a while, where multispectral is required, and if the sensor can helps them out.
Yeah, I see here many people from environmental monitoring, people from agriculture as well, people from research and investigation. There's some professors as well here, I can see on the list. Okay, we have over 130 already. Should we start with the webinar?
Let's just go ahead.
Okay, perfect. Welcome everyone to the webinar. This is great to have you. I am Julian Mackern, P product at Wingtra, and here is Erik de Badts.
Yeah, my name is Erik de Badts. I'm working at Micasense already for quite some years, and I'm happy to do this with Julian, which besides my colleague at Wingtra is also a good friend of mine, so I'm happy to do this together with Julian. And yeah, let's just start.
Yeah, sure. So before we start, you can all write questions and answers. We will leave a space for 10 minutes after the webinar, so we can also answer all the questions over there. So feel free to type the questions anytime, and we will answer after we speak. So again, I'm the product manager at Wingtra, special for multispectral, and Erik is our business development manager at Micasense. As he's saying, he's a friend of mine, so it's good to be working together again and pushing this bundle together.
Yeah, so happy to do this also in English for this time. I used to do this only for Latin American and Spanish-speaking countries, but from now on, I'm also in charge of our European business. So we had some restructuring at Micasense, like some of you guys might know. It's now part of the Ag Eagle company, and luckily our sensors are still the same reliable ones. And so thanks, Julian. Let's start with the agenda.
Great. So we will be talking about collecting high-resolution data with the WingtraOne Gen II for everyone who doesn't know the equipment or who knows it and who would like to know a little bit more. And then we will go talk a little bit about panchromatic and multispectral imagery. And then Erik will explain why resolution matters. So we will explore some high quality outputs from the Micasense RedEdge panchromatic. And then we will talk about the WingtraOne with the RedEdge panchromatic, and then go to the questions and answers. So first we'll do a short poll on if you're already working with multispectral imagery. So I would like to know about this. So you can see this on your screen. So please answer whether it's a yes or a no. It would be interesting for us to understand where you are now, and if you are new to this, or this is something you're already working on. So interestingly enough, I would say half and half, 46, 54%. So thank you, all of you who are answering the poll. This is great to have the information from you and in your insights. So this is good stuff. So already got 91 answers. So yeah, 48% of the people are already working with multispectral imagery, and 52 not yet. So yeah, this is great. Thank you for the answers. So I will continue. So we have developed a drone that's a VTOL, that's a vertical takeoff and landing, and this enables to do really map large areas and fly like a fixed wing. But the importance here is that you takes off and lands like a multi-rotor. So this really is good for protecting the camera and for protecting the drone in every flight. So this is why we have developed this drone that can basically take off from anywhere in any situation. And here's a little video that explains, these are some flights of our customers taking off in mine sites, taking off in forests, or even from boats. And that's how the drone transitions into the flight mode. And it takes pictures as a fixed wing. And then when it comes down, it just lands as a multi-rotor. So this protects the camera and the drone. So we have customers in many different industries. So coming from surveying and GIS to construction and infrastructure, mining and oil and gas, and also agriculture and environmental monitoring. So this is mainly where customers are using multispectral sensors, such as the ones we have from Micasense, and now with the RedEdge-P is probably the most interesting would be for agriculture and environment. And this is very important because the drone is super versatile into having different payloads that you can change. You can change in a few minutes. It's very easy to exchange. They're all connected, well connected to the autopilot for the triggering, and also to do PPK georeferencing. We can talk about that a little bit later on. So sorry about this, my presentation. Yeah, so okay. So here are some pictures all over the world. There's Wingtra customers flying. So you can also see that there's different payloads. Again, going from multispectral to RGB cameras, there's all sorts of different payloads and flying in very different situations. And a lot of them are flying in windy conditions, in coastal monitoring. So this is also very interesting to see how the drone can deliver reliable data in hard conditions. So when it comes to remote sensing, there's many people flying with satellite or mapping with satellite imagery, which is really good, and really it's a very good complement to drones. But the problem is that it has low resolution, that the satellite goes every X amount of days, and you cannot program when it passes, and also it doesn't gather image if there's cloud cover. So that's why drones are important here, to gather better resolution imagery whenever you want. But the difference between WingtraOne and other drones is it's how much you can map in a short time and how you get reliable data. So this is also very important, and the ease of use. So this is something that we have worked on for a very long time in order to make mapping a lot easier. So what I want to highlight here is how you can do a lot of work in a short time. So it's flying large areas, and because the drone flies like a fixed wing, it flies really fast, and this can gather a lot of data. And here it's important to have cameras that can capture fast. So this is why we have worked a lot with MicaSense, because now with the RedEdge-P, you can capture data very fast, and you can do a big job in in a short time. Also, the fact that it's very reliable, not only to fly in high winds, but also to make sure that it gets all the images it needs and it gets them on the specific places. It's important because after you do the job, you go back home and you know that you have all the information that you need. And the third pillar we have is it's a drone that's very easy to use. And this is very important because anyone can take the tablet, draw the polygon or draw the corridor they want to map, and they just press fly and they just go flying. So this is very, very easy for most customers who do not want to get into model planes and just want to have something that's very easy to use. So before going to Erik and explaining a little bit more about cameras, I would like to have another poll, which is what use cases are you working on? So this will give us a little bit of an insight on where you are now and what you're doing at your work. I guess that most of you already answered this question when you signed in again. So thank you for that. That's also very insightful for us to know about you and know what you're doing with drones, and now especially with multispectral cameras. There's many people who answered other. There's 16 of you. That would be good to know if you want to put in the Q&A, if you want to write down what you're working on. That would be also very interesting to see. Okay, with 100 answers, I'll end the poll here. And interesting to see that almost a third of you are working in agriculture, then some in environmental and research, in surveying, and in other businesses as well.
Mm-hmm. Yeah, very interesting, you know, because the uses that people are using drones for mapping is ever expanding. I can imagine that many people also working for nature conservation are working on this. It's the questions we got from people, if we can use it for this or another application, it's incredible, because you learn how the amount of industries that are using this kind of data as well, you know. So yeah, probably we need to extend the list for next webinar.
Yeah, I remember discussing this with Erik many years ago, people coming from archaeology to asking for multispectral cameras and from forestry. And yeah, there's many more industries as well.
Yeah.
Great.
So yeah, thanks, Julian, for the presentation about WingtraOne Gen II. Very interesting. So yeah, this is my part about the RedEdge-P, the P of panchromatic. It's so interesting because myself, I come more from the satellite industry. That's what I studied, you know, like way ago back in time. And there was already for the Landsat images at that time, you got the panchromatic band and with the multispectral bands of a lower resolution. And we used to do this fusion of the data to enhance the data. And I never asked myself the question why. But now, since I'm more involved into the sales of this kind of cameras and the reason why you have a panchromatic side camera on one side and the multispectral sides on another one, it has some really good valid reasons to design a camera just like this. So first of all, this camera, it has the same 5 bands as the RedEdge Max band, as the RedEdge Max camera, which has been already around for 6 or 7 years. It has never changed since, but this year we need to discontinue the product, unfortunately, because there are some components we can't source anymore. But gives us the opportunity to talk a little bit more about this camera, right? So it's remarkably better and different, and at the same time quite familiar than our other sensors. It has the same web integration through the Wi-Fi. It has just also one button to take one picture of the calibration panel, because the data quality is as important for us as that's always been. That's actually our trademark. The big difference as well is now that we use the compact flash memory card, and that enables the camera to take much faster the pictures, right? We have listened to our customers. So, okay, we like your cameras, but we would like to have first a better resolution. And secondly, faster capture rate. Yeah, faster capture rate means you can fly lower and or faster. So that's important because our sensor really needs a very high overlap. Multispectral sensors need more overlap than RGB cameras. That has more to do with the calibration of the data. It has automatic opening times, so it needs to be have a lot of overlap. So that's the thing. That's why it is so important to get this fast capture rate, and that means you are producing an enormous amount of data. For that as well, that's the reason why we have this panchromatic camera configuration, and that has to do with the amount of data you generate during the flight, right? So it comes as well with the same DLS light sensor, exactly the same one. It has integration for PPK for the drones that offer that kind of integration. In this case, Wingtra offers the integration. We've tried it out. It looks great. Good precision. Maybe Julian can talk us a little bit later about the outcome of these the tests they did. So yeah. This is the sensor. It comes always with the calibration panel as well, of course. You can switch to the next slide.
Yeah, I'm trying to switch. Okay, here it goes.
Yeah.
Can you see it?
You can go one. Yeah, but it's yeah.
Okay, here it is. Yeah.
This one. Here it is. So yeah. So what's the panchromatic band? It's just a grayscale band. It's just actually a black and white picture. Yeah, and it englobes the whole visible and near infrared spectrum. So everything comes in and you get back one single value. So that's the black and white camera. So it has all the components of the different colors. So it's not actually, when you take pictures with the camera for the blue and the green and the red, those who have worked already with multispectral images, when they look at the pictures on the memory card, they are actually also all black and white pictures, but only with reflectance values for those filters, for those bands. Yeah? And the panchromatic here englobes it all. So what we're doing now is, first of all, what is panchromatic? So it's one single band of grayscale image. And the good thing here is it has a higher resolution. And why not an RGB camera, right? So why a black and white picture, another color picture? Why can't we use the color picture in one time? That's because how these sensors are made. First, it is important, first of all, to have a global shutter for the data quality, not a rolling shutter. So that means that you're quite limited on the amount of pixels you can use, maximum. So an RGB sensor is like 40% green cells, and then you have 30% red cells and 30% blue cells, more or less. So that means actually that an RGB camera of, let's say, 12 megapixels is actually less than 4 megapixels of real spatial information. And if you have a black and white camera, you can take use of the entire array of pixels for spatial information. Yeah. So that actually, this camera, the panchromatic camera, is only 5 megapixels, but it actually is comparable to almost 18 or 20 megapixel RGB camera. So that's the real resolution you can expect, right? So, and then the pan-sharpening, what does that do is mix those, the grayscale image with each of the multispectral images with a lower resolution. One more time again, why don't you put this high resolution for each of the 5 sensors? We can do that, but that means that it's a lot more data you need to acquire, much more megabytes for each capture, right? So, and the advantage of having up to 3 pictures per second is too high, and because we need to optimize our time when we're mapping, and if you can fly fast and lower the altitude to get even a better resolution, that's really the way forward to go to. So the fusion of these images, this is a result that you can see on one side. It's just a RedEdge Max with 4 centimeter at 60 centimeter, before and after fusion with the black and white high resolution band. probably we can get questions here about the data quality, yeah, about the reflection, because we always talk, when we talk about multispectral sensors, the quality is so important that we have the calibration panel, we have the DLS, we need the reflecting values, we need to have them precisely, and then you mix them up with a grayscale image. How does that affect the reflectance values? It does affect, but very slowly, very little bit. You can get around 90-95 reliability on the real reflectance values of the pixels after pan sharpening. Of course, it's not an obligation to do the pan sharpening. That's the other one. Thanks. So the narrow bands, that's also a difference, the difference because you have we have a blue channel, a red channel, and a green channel. So with these three, you can make an RGB image. And if you compare, in this case, the X4 from DJI with 2 centimeter pixels, and on the lower side, you have the RedEdge-P with 2 centimeter pixels. You can clearly see that it's the images from this sensor have much more contrast. Yeah. So if we talk about resolution, and that's interesting because this is the first sensor on the market that makes pan sharpening, the whole concept, and that makes us talk about resolution. We talk about megapixels of the camera, of course, but now if we have black and white camera and RGB camera, it's not the same anymore, the megapixels, what you're talking about. Talk about the ground resolution, also very important, but you need to also talk about the contrast. Yeah. And since we have these distinct multispectral bands for which we make this RGB image, you can clearly see the importance of the contrast. And you need to go to contrast, for example, for the separation of the plants, for plant counting in this specific application. But you can also see it directly on the RGB pictures that you can make with this camera. So yeah, here you got an NDVI image, but here you can see clearly in this RGB image and false color composite how the high contrast, and the colors, they are so vivid, things that you cannot ever obtain with the normal RGB cameras because of the configuration of the pixels on the sensor, makes that they are all a little bit mixed and fused into one to another, and these colors, these contrasts, make that you can get really beautiful pictures, now really competing with the best RGB sensors because of the contrast actually. And apart from that, you get radiometrically corrected data in reflectance values.
Yeah, here I want to make a little bit of emphasis, Erik, on how low you can fly, and this is very important. What Micasense has developed, this triggering, fast triggering, because you can fly low even with the WingtraOne when you're flying very fast. You're flying at 16 meters per second, and this can get you to a plant level detail. So starting to analyze the plants and this level of detail makes it super interesting for most applications.
Yeah, that's right. So we really try to stress the camera using the Wingtra because it's one of the few drones that can fly so fast and so low. And we made a really nice map. And of course, the resolution is important. It depends, of course, for the application. If you are making fertilizer application for a wheat field, it's not that big of a deal. But for plant counting and for image classification, habitat classification, and even getting really nice digital elevation models too.
Yeah, if you can talk about that, that would be great to see the 6 sorts of mistakes you create actually with the camera.
Yeah, so the RGB, the RedEdge-P creates always the 6 orthomosaics, and they are fused together. One is the panchromatic one, and then you get each for one of the bands. And that this is an example. This is our test field in Seattle, actually, where we do all the test flights. So this is one of the first maps we made with the RedEdge-P a couple of months ago. And if you go to the next slide, you can see here the digital elevation model. So it's really odd because for surveying applications and RGB cameras and everything you can do with drones and mapping, it's many times it's about the digital elevation model and not as much the imagery as such. While for us, multispectral cameras, it's always been about the imagery, and the digital surface model has always been like a REST product, which is like generated anyhow, but not really worthwhile using it. Now, with this high resolution that we have, and with the PPK functionality, we really feel confident to deliver high DSM, high quality DSM models. So that's why that was one of the reasons that we asked for, okay, what you're doing with this camera. Are you already working with multispectral? Would you consider using this camera also for making contour lines, which is perfectly possible with this high resolution global shutter, right? Also, very important, and that's, well, MicaSense cameras, probably 30% of our users are researchers. And of these researchers, a big share of them are working on phenotyping. Yeah. It's interesting because the drones and the multispectral sensor are now really part of how phenotyping is done and evaluated. The data that are collected are, by default, drone imagery included. Many software platforms are working with this and to handle these data. And here always the question is, we need a better resolution. Yeah, and that was actually also the biggest critic we got for our Alton camera. You can get a good resolution, but for phenotyping, we really need to have like millimeter, centimeter level. So that means flying at 30-meter height, 40-meter height, and the Alton could only take one picture every 1.5 seconds. So that means flying very slowly. And now, if you can take so many pictures each second, you can fly much quicker and get more data maps, comparable data, of course, in time because of the reflectance values. And also, many people say, okay, we need the multispectral camera, and besides, we put an RGB camera for the resolution. The idea is now that with just one camera, you can do it all in one time. Yeah. So we are really waiting for the first results of our users to come back with the real feedback, because now what I'm saying is just what I hope they will say.
I see some participants that are here that actually fly with multispectral cameras with a Wingtra, and then they fly again the same field with an RGB because they were actually looking for a high resolution orthomosaic in RGB, or even to get, as you were saying, to get a DSM. So this is very, very interesting that the RedEdge-P delivers such a good data that you don't need to fly twice. You only do one flight and you get all the data you need. Yeah.
So we are actually waiting for the feedback of these customers that they can confirm this, right? We are looking for that, please. If you have this kind of configuration, what we're proposing here, come back with us with all your comments and ideas. We are really eager to learn about it. So also interesting, and that's for our users of our cameras, it has always been like 100% agriculture. And right now it's like 30% environmental monitoring. Our environment is changing. We need to take care of the environment, of course, and then we need to follow it up. And for that, we need multispectral images for habitat mapping and land restoration projects, all kinds of uses you can give to it, coastal monitoring. And here also, we are talking many times about very large areas, right? It's just not one manageable agricultural field or not even a phenotyping test field. Here we're talking about wilderness, nature, hundreds, thousands of hectares, where it is important that you can get the hectares. So Julian, why don't you tell me, taking into account the very high overlap we need with this multispectral sensors, how much can you map with one flight?
I mean, flying at 400 feet, 150 meters, you can fly about 150, 160 hectares in a flight. Depends a little bit on the wind conditions, but yes, you can map large areas. And again, this is super interesting, what you're saying, Erik, and we have been working with Wingtra for the last few years a lot in mapping in windy conditions, not just for the takeoff and the landing, which is important, of course, but also to be able to map straight lines and to fly straight lines. And this is very important, as Erik was saying, for the overlap, because if your drone cannot fly straight lines in gusty conditions or in high winds, then the map will not come out okay. So either if the drone can fly but cannot capture the images where it needs to take the images, then the work is not done. So this is also why we actually work so hard on flying well in windy conditions. And here is where the RedEdge-P makes a huge difference, because sometimes if you have a little bit of tailwind, then you need to trigger faster than what you usually do. And this is where the camera makes a big difference. So we're super happy that this integration can actually help our customers.
At this time, it is the Wingtra autopilot that triggers the camera, right?
Yeah. That is correct. And not only it triggers the camera, but also gets the information, the feedback from the camera for the PPK geotagging. And this is something that is very interesting, the PPK. This is a method, so you have either RTK or PPK to geotag the images precisely. And the PPK is a post-processing kinematics. And this is what you're doing, is you're basically connecting the information from the flight with a base station or with a course network. You can connect them in a software after the flight. So you don't need connection with the drone during the flight. You can do it in your computer, in your office or at home. And you can basically geotag the images with very good precision. Actually, we made several tests in different places, and we managed to go down to 3 centimeters precision of absolute accuracy. So that gets super interesting in every case where people fly over the same field several times and they want to overlap their maps, and they want to see precisely if there's a problem that is growing, or there's a pest that is moving somewhere, or they want to see a specific plant that is going through a process. They want to see it over time. It's very important that these maps actually overlay precisely.
Yeah, very important. The temporal resolution. Talk all the time about the spatial resolution. Actually, the repeatability of your data in time is for many applications just as important.
Do you want to mention, Erik, this radiometric, which you already mentioned before, but how important this is for people who already map with satellite imagery and how they want to compare the maps or the indices?
Yes, of course, because the universal language of multispectral images is our reflectance values. So these values are comparable with the satellite data, with with ground measurements, in order to relate them to biophysical parameters of the plants, of course, the vegetation. And for that, of course, we have other kinds of resolution: spatial resolution, spectral resolution, the radiometric resolution, the pixel depth. So our images are not just 8-bit; they have 14-bit geotiff information. So that means it's a lot of information. So in the very dark part, in the very bright part of the images, you can still see the differences, right? And that's important, especially for very healthy vegetation that has lots of reflectance values in the infrared part, and also the temporal resolution, right? So that's important. Again, since we're talking about PPK for environmental monitoring, it's very challenging to put ground control points, or if you map very large areas, you really want to work this way. And of course, it's not perfect, especially if you have a very small pixel of just 2 centimeters. I think with PPK, correct me if I'm wrong, Julian, you can get like 4 or 5 centimeter precision, absolute precision. So that means you still have to switch a difference of 1 pixel, but for most applications, that's more than enough, because plants are always consisting of many pixels. It's not that 1 pixel has different objects; it's more the other way around. So it's still within the margin of error for all the applications. We require this temporal resolution.
Yeah, I can correct in that. We managed with the RedEdge-P to go down to 3 centimeters because of how low you can fly and the resolution you get. So that's very interesting. And just answering the question, one of the questions they have here is if we need ground control points, and the answer is that no. With RTK or with PPK, you can fly without the ground control points. Can you talk a little bit about algorithms, Erik, in agriculture, and how you can detect plants or count plants?
Yeah, there are so many things going on, so many companies, interesting startups that are from Switzerland, from Sweden, from the US, even from Brazil, that I know. They contact us to get data for this kind of plant counting algorithms. People, of course, they can do it themselves in QGIS. There are people working with how do you say, image recognition, all kinds of things that I really have no idea about how it works. But people use the images and take use of the constant values, because it's not just about the form of the object you want to count, but also the thresholds you can establish to determine whether an object is a plant or a fruit, or it is not. So it is important that the data are standardized, because if you have your training data set and you want to establish your algorithm, you want to use thresholds that are robust enough so you can repeat the same algorithm in another image. So that's one more reason why it's so important to have good quality and correct calibrated data. Yeah, and like that, you can work with disease identifications, species differentiation, plant counting, phenotyping, and plant health all over. Yeah, and it has always to do with the same data quality if you want to develop robust models.
Great, thank you for that. I wanted then to recap a little bit on what we're talking about. So the drone, we believe that the WingtraOne GEN II is best for maximum efficiency, accuracy, and again, to emphasize how easy it is for anyone to go out there flying with the drone, and especially now that there's this good integration with the camera, and the camera gives a lot of feedback to the autopilot, so this is very well connected. And how MicaSense has developed this camera that really makes it easy for people to get really good data. And here I want to talk a little bit about processing, because many people will come with questions on if we can already process RedEdge panchromatic pictures. So here to you, Erik, what have you worked with Agisoft and with Pix4D?
Yeah, with both. Agisoft gives a quite good outcome, and there you have available like a formula you can input into Agisoft so that they can make the kind of pan-sharpening. There is just one method to do that. But we also had the very privilege to pre-announce the Pix4D Fields 1.12, which will come out next week and has the panchromatic, the pan-sharpening option included in the next version of Pix4D Fields. So that makes us very happy, not because you can pan-sharp the image, but you can actually compare one with the other one. For those who know Pix4D Fields as a software, you can there's a very nice sliding tool, so you can compare between different indexes, RGB image and the NDVI, for example. And now you can have also this sliding tool that you can compare between after and before pan-sharpening. So you can really see here now the difference, because you can talk about pixel resolution and whatever, but the most convincing is to show the real difference and be able to compare it in this software. So I'm really excited to have my first version of the software and try that myself.
And this is flight we did together. We had the opportunity to fly together with Erik some months ago over a palm tree plantation, and I was very impressed with the resolution and actually seeing the RGB orthometric, of course, and be able to zoom in and see the high definition. But it's also very interesting to see for people what MicaSense has done. You can click in that palm tree viewer. It's actually online, and then you can find it easily. And if you don't, you can look it up in our webpage or in MicaSense webpage. It's there to see. Do you want to tell a little bit, Erik, about what you did there with the vectors?
Yeah, so we did this actually with the very first experimental camera with the RedEdge-P that we made. So we took it down here to Argentina to try it out. And so on one side, of course, you have the RGB image, and it's such a nice example actually, because this palm tree field gives us the ability to do everything what you can do with a multispectral sensor for agriculture. So you can do the plant, like you can see here in the example, you can see the different plants. So you can identify them, you can count them all. Then you can have the NDVI values for each pixel, and you can determine the mean crown size of each plant. And of that crown size, determine the mean NDVI value of that plant. So in the lower image, you have like the size of the crown, the color reflects its biomass, and of course, since it's converted into a vector format, you can do the counting. So if you can see, if you are wondering why on the former slide, on the borders there are so many more trees than in the middle, that's actually quite a straightforward question if you look at it. It's not really an agronomical reason for it. The owner just did it to form a kind of windscreen around, because it's a little bit a windy zone. So to leave the bigger plants on the sides protects the inside, and they can, yeah, for some reason they prefer to work like this.
Yeah, it's easy to actually see that in plant counting on RGB. Yeah.
Yeah.
Great. I think we can then jump to the questions and answers. Can you see the questions, Erik, as well?
I can see the questions, yes.
So there's some questions for me, for example. If flying in high winds, better to fly parallel or perpendicular to wind? The answer is to fly perpendicular, because if not, you have tailwind, or you have wind that will slow down the drone, and that's not very good, especially with a tailwind, because although it can trigger very fast, if there's very fast wind tail, it's going to be hard. So usually you can fly with perpendicular wind. And what's interesting about the Wingtra, again, is that it manages to actually fly without needing a gimbal. It can still capture the image with like very good precision, and with the overlap you have. And again, Erik was mentioning the high overlap. We're talking about 70-70, Erik?
Yes, indeed. But 70-75% really guarantees you very good results. Right. But we have also tried that if you have optimal climatical conditions, and you need to do 2 flights because you have 70 centimeters, you can lower it maybe to 60 if the climatical conditions are right, and your data will be perfect as well.
Yeah, so yes, you can fly with perpendicular wind, and the overlap will ensure you that although some pictures will be a little bit to the side, the maps can be created without any problem. Some people are asking when we'll ship this first camera. So first cameras will be shipped on 1st of June to all of Wingtra customers who already bought the camera. That's the shipping date. Do you also see more questions, Erik, there?
Hello, what's the lowest possible flight altitude with WingtraOne and RedEdge-P? Interesting one.
Yeah, that's a very interesting one. And we decided to put the limit at 60 meters. Just because of security reasons. That's 195 feet. It could fly lower. I mean, from a hardware and software perspective, it could fly lower. But we do set the limit at 60 meters just because of security and the height of trees and height of buildings.
And I have here an interesting question as well. With the RedEdge-P sensor, do you have control on shutter speed, ISO, exposure, etc.? Or is it automatically determined and applied to the sensor based on the flight parameters given in the flight planning software? So here we're talking about the camera as such, right? The camera right now takes pictures in automatic mode. So that means that the pictures, depending on what's on the ground and what are the light conditions, might have different exposure times, and that the colors of the pixels are a little bit different. So that's one of the reasons we need such high overlap, because we need to have a mean values. You can switch into the configuration of the camera to fixed opening times, but for that you really need to know what's the light intensity of the moment in order that your pictures won't be too clear or too dark. But it's perfectly possible to work so, and then possibly you can fly also with a lower overlap.
Great, thank you for that. Just a question here about the Wingtra planning applications. We call it Wingtra Pilot. It's very easy to use. Actually, you can plan the flights on the tablet. The Wingtra comes with a tablet, or you can plan it on the computer. There are actually several demos every month that you can watch. So I encourage people to watch the Wingtra demo, in which they will show exactly how to do that. So we don't spend time on that here. There's a question here, Erik, if the resolution of the RedEdge-P can be used for surveying work. What's your opinion on this?
It depends who's asking the question, if it is Leonel Caputo or not. I think it is, and that's really the feedback that we want to hear, because we know surveyors working with drones, they once in a while they have the question, hey, can you do multispectral mapping? But it's an expensive camera, and let's try to just do it with RGB, because the bulk of their work is survey work. So the resolution combined with the high contrast and the PPK integration should deliver as good or even better results than you can make with RGB cameras. Depending also if you are just working for the DSM. The resolution is important, of course, but you certainly need the best data quality, and that's ensured by the global shutter of this camera. So we are really looking forward of surveyors doing their job with a multispectral camera.
Great, thank you. There are several questions here related to Pix4D fields, Pix4D mapper, Pix4D products, Pix4D Matic also. And what we know is that Pix4D fields has released, will release next week the 1.12 version that can do the pan-sharpening. Pix4D mapper or Matic cannot do this, and I am not sure they will do it or they will have it on the roadmap. Do you have any idea?
Yeah, we'll Micasense and Pix4D will do a webinar about this in the coming weeks. It will be announced shortly, and for sure many of these questions will be answered there. Right now, Pix4D Fields is the software for getting best results with multispectral images. There's another interesting question here from Yves Lantin. Hi, Erik. You talk about RGB and color composite advantages with the panchro for classification, generate digital terrain models, and so on. But do you also recommend it for index calculations, or is it better to use the normal resolution for this? So that's interesting because the data quality is only guaranteed with the pure multispectral bands. So before the pan-sharpening with the panchromatic band, with the black and white band. Difference is about 5% error maybe. But if you make a classification, depends on the software you're using for. So we see here an increased use for environmental use of software like Ecognition, for example, segmentation of images where you need a high resolution image to delineate the objects. Since each object consists of many pixels, it's not the other way around like in satellite imagery. And then you can assign very 100% pure data quality multispectral information to those objects generated by the high resolution bands. That would be a nice workflow for classification of the imagery.
Great, thank you for that. There's some people here asking for return of investment. If we can talk about that, and we can compare that to older, cheaper technology like the Parrot Sequoia. And this is probably one of the most interesting topics, and we discuss this a lot when it comes to talking with customers who want to know about the ROI and how we can work on this. And here we believe that the WingtraOne GEN II with the RedEdge panchromatic, it's a great bundle actually to do the work and to actually get your investment back. I think this really makes a big difference because you can map large areas, as we were saying, still gather really reliable data and also get it in a short time. So this helps people to actually not spend too much time on the field, not be there mapping for a whole week, but actually do that in a matter of hours. And this actually makes it very, very easy for people to understand how to get their money back. Do you want to add something there, Erik?
Well, I think we are already a little bit over time of the 3/4 we foreseen for this webinar. So we have like 15 more questions open we can answer by email. I think we covered the most important and interesting ones.
Yeah, of course. Thank you very much for all the questions and for answering the polls. We will come back to you answering the questions, and please feel free to send us emails or be in contact with us. We will continue talking.
Yeah. So thank you, Julian. Thank you the whole Wingtra team for the organization of this webinar, for the launch of this interesting combo, because we have a new Wingtra, we have a new camera, and we have the luck of a Pix4D Field that just come out with a perfectly aligned software product with this combo. So it are exciting times and glad to see improvements in the industry overall. Thank you for this interesting webinar.
Thank you very much. Bye, Erik.
Bye.